I find the topic to be pretty confusing. Some of you guys, like, you're going to see it and you're going to get it right off the bat. It's going to make me crazy because it's really instinctive and intuitive to you. For many of you, if you're like me, you have to really methodically think through what you're doing. There are some good resources online on the School Loop Locker of color wheels and explanations, and there's like a synthesis page that has all of the stuff I'm talking to is kind of on one piece of paper and it's in color, so you could print it out and use it to review in your notes. So look for it there up on School Loop. Okay, so first of all, we have talked about the electromagnetic spectrum, and what you understand is that light is just one small portion of a wide-ranging spectrum, visible light. Okay, so we go from 700 nanometers for red to 400 nanometers for violet. And you see the colors of the rainbow. If you take white light, now we've tried this demonstration in class, and it's hard to do it with a prism, and for you guys to see it well, I do have a little holographic grating that you're going to be able to see it. But we can take white light, and we can separate it into its spectral colors. And so that's what we're going to do right now first. And so we plug in our little filament, and we put our holographic grating in front of it, and you can divide the white light into its spectral colors. So Newton understood, in fact, that white light was made up of various different colors that were brought together. He actually spent a lot of time kind of studying that idea. So we talk about primary colors. And what's weird about primary colors in physics is they're different than the primary colors you learned about in kindergarten. These are primary colors that are related to light. The primary colors of light are red, green, and blue. If you mix those three colors together in various combinations, you can get all permutations of light. If you combine these three distinct colors, red, blue, and green, you can form white light. That seems weird because you're used to crayons and paints, and those are pigments. And we'll talk about pigments at the end of the period. Those are what we call secondary colors. Primary colors are red, green, and blue, and you combine them together to form various colors. So if you take a look at our cool little light box here, you see that by combining the green light with the red light and the blue light, in the middle you have white. They have really cool demonstrations like this at the Exploratorium too, if you want to check them out when you're there. Okay, now you hopefully also notice that where you have red overlapping with blue, you get a nice little color here we call magenta. Where red overlaps with green, you get yellow. Again, that is counterintuitive to what you learn with your dealing with paints in kindergarten, so you got to relearn this stuff. And then blue and green light give you cyan. If you guys play around in theater production, you'll see that the whole lighting scheme is very different than what you might think. So you have to kind of relearn the whole color scheme. So I can dim one color. So if I dim out right now, if I dim out the red, then you see I get this beautiful cyan showing up. And if I dim out my blue, what are you going to get? There it is, really sharp. And then the last one, what did I dim out here? Green, there we go. We get a really pretty magenta. Okay, so by coloring and overlapping these three different lights, you can get white, or by doing different intensities of R and G and B, then you can get different colors in the spectrum. When you're dealing with computers and trying to figure out a different color, one of the color schemes you can use is RGB, because on your TV screen, on the old-fashioned TV screens before you had plasma, what it really was is little pixels. There was a little red, green, and blue, and the little electrons would come in and they'd fire on these different little colors, and the right intensities would give you a color screen. So that was a big innovation in technology when we first developed color TV. So if you're going to combine your colors, we call them additive colors. When you combine two primary colors, you get your secondary colors. And I like to do it, and whenever I'm doing a problem that's dealing with colors, I just make myself a little color triangle. And it looks like this. And I just go like this. I just make a triangle, and I go RGB. Okay? I go RGB. And I remember what combinations, I should be doing it on this little thing, but I don't have it. I don't have a little stylus. Does anybody have a stylus, a little iPad stylus? I keep one in my math room. I don't have one here. Okay. Let's try to do it. So this is the way that people at home can see. So if I make a little triangle, oops, that's not a triangle. Let's make this. Triangle like this, and I say R, G, B. And that helps remember. And then I think, okay, if I combine R and G, then I'm going to get magenta. If I combine, I'm sorry, did I say R and B? If I combine red and blue, I'm going to get magenta. If I combine red and green, I'm going to get yellow. And if I combine green and blue, I'm going to get cyan. So when I'm doing a color problem, I just automatically sketch this on my paper. Now, some of you guys, like, you see it, you don't ever have to sketch it again. It's just totally in your head, right? I admire you. You're like the people who learn languages after you hear things once. I don't do that. It takes me forever. So that's a little thing that you can play around with and use. So this is our demo. We've already kind of seen it. I'll come back to this one in a second. Okay. Complementary colors. Complementary colors are the color that you combine to create white light. So, for example, let's say you had blue. Okay, look at blue on the color wheel here. What would you combine with blue to get white light? You can only combine one color with it. Which color would it be? Yellow. Yellow. It's the opposite on the color wheel. Do you see that? Because yellow is a combination of red and green. And if you combine red, blue, and green, then you get white light. So complementary colors are essentially the opposites on the color wheel. So green with magenta, red with cyan, blue with yellow. Because basically you're folding all three colors into one whenever you make those combinations. Okay, so example, blue plus yellow, which is really blue plus red plus green. Okay, green and magenta, and then red and cyan. Those are all of your complementary colors. So if you draw your triangle, you take the vertex of one side and the side opposite of the other to find your complementary colors. Okay, color filters. What are color filters? These are filters, by the way. Here's a little red filter. Can you see it? Okay, a red filter. What does a red filter do? What a red filter does is it absorbs some color and it transmits other colors. So a color that gets through is the one transmitted. So a red filter transmits red light, and it absorbs everything else. So if you look at the color wheel, you'd say, well, what does red light absorb? What does it absorb? Blue and green, right? It absorbs blue and green, and it lets red through. A yellow filter lets red through, which means it transmits red and green, and it absorbs blue. Okay, so think about this. Like, what is a green filter? What does a green filter absorb, and what does it let through? What does it let through? That's the easy question. Green. And so then what does it absorb? Red and blue. Okay? So that's the idea of a filter. So here's a practice question. What color does a cyan filter absorb? Okay, a cyan filter is going to let through cyan, which is a combination of blue and green. So what does it absorb? Red. Okay? One of the really cool things, have you heard of, you know what cataracts are, right? So cataracts is a condition you get when you're older, in your 60s and 70s, and you get this kind of yellowing of your lens, and it gets hardened, and it gets so thick that you can't really see through it. So in the United States, we take out cataracts pretty early on when they're not really bad, but if you go to third world countries, they get terrible cataracts, and so they can't see anything. But one of the things that you'll hear a cataract patient say after they've had their cataracts removed, and what they do is you take out the lens and you put it in a new clear plastic lens. In fact, one of our, my husband is going to come in. He comes in every year and does a guest lecture on optics in the eye, and so we'll talk about cataracts. But one of the things that's really cool is that when people get their cataracts out, they come in the next day and are like, wow, the sky is so blue. Because they've had this yellow filter in front of their eyes that's been absorbing the blue. And so they've never really seen the blue for the last couple of years. They haven't noticed they haven't seen it until they've gotten that yellow filter removed and they're like, whoa, I had no idea that the sky was so blue. Okay, practice with filters. White line shines through a magenta filter. What primary colors are absorbed or transmitted? Okay, figure it out in your head. Magenta filter, what colors are absorbed or transmitted? Kyle, what do you think? Very good. Why do I always pick on you? I don't know. Because you always look sort of disinterested, but then you're totally on it. You have that disinterested look, but you're totally into it. Good. So you have white is red plus green plus blue. Magenta is red and blue, so magenta is going to be transmitted. That means that green has to be absorbed. Okay? All right. Yellow light shines through a magenta filter. What color will the filter appear? I'll go random so I don't pick on Kyle. Actually, if I do that, then I'm going to have to pick a sophomore, I'm sure. Nick, what do you think?
Magenta.
Magenta. Yellow light shines through a magenta filter. So yellow only has red and blue.
Oh, well, the filter. Oh, when it's going through, I was asked that, like, color filter.
So what do you think now? Yellow light is a combination of what two colors?
Red and green.
Good, red and green. So I'm shining red and green through a magenta filter. So what gets through?
Red.
Red. Yeah. Good. Yellow is red and green. Magenta absorbs the green, so the filter's going to appear red. Okay? My, what a nice shirt. Your perception of colors in clothing in nature is we perceive color because those colors are reflected back to us. So if you have a yellow shirt, it's because your shirt absorbs blue and reflects back red and green. So it appears to us to be yellow. So blue jeans, blue is reflected, red and green are absorbed. A yellow shirt, red and green are reflected, blue is absorbed. Okay, so that's what's happening when you're seeing a color of a shirt. We call those colors that you're seeing or perceiving pigments. Now, when you're talking about pigments, now we're talking kindergarten. Now we're talking mixing finger paints and combining colors with watercolors and crayons and all kinds of stuff, right? So pigments, paint, ink, etc., they're called subtractive colors. Primary colors are called additive colors. So these are, pigments are, or I should say light are considered additive, and then these are considered subtractive. They take color away, they absorb, and then they reflect what's left. So green leaf reflects green and it absorbs red and blue. So here we go, let's practice. A magenta light is shined on a yellow shirt. What color will it appear? Okay, magenta light shined on a yellow shirt. What color will it appear? Karen, want to take a stab at it?
Green.
Is that right? I haven't even thought about it. Magenta light is red and blue, shines on a yellow shirt which reflects red and green, so it's going to appear red. It's going to absorb the blue, right? Magenta is red and blue, that's the light. A yellow shirt absorbs the blue and reflects the red and the yellow and, a yellow shirt reflects red and green, but since it's only seeing red, it's going to reflect the red. So a yellow shirt will appear red if you shine magenta light on it. That's trippy, right? You have to really think through that. So this stuff isn't easy, but with practice it gets easier. Again, when I'm struggling with this, I make my little color triangle and I remember the relationships and figure out how you can combine them together. Okay, your secondary colors are also your pigments. So your primary colors, RGB. Secondary colors, CMY. Cyan, magenta, yellow. Okay, those are your primary pigments. So if you have cyan paint, crayon, ink, whatever, if you combine those with various intensities, you can reproduce the entire color spectrum. And that's what you're doing on paper, right? When you're coloring on paper, you're creating a pigment. If you've played around with graphic art at all, when you're creating precise colors on a computer screen, you use RGB because you're combining different forms of light. When you're creating a t-shirt design, you use CMYK. You heard of CMYK before? Does that ring a bell? When you go and buy new ink cartridges and you have to replace your color ink, you get CMYK. Cyan, magenta, yellow. And what do you think K is? Any guess? It's black. Don't ask me why they made it a K. But because if you combine your secondary colors, just like when you combine your primary colors, you get all three primary colors, you get white. When you combine all three pigments, you should get black. So if you know how like we took all your different colors and you put them all together, you get this really ugly brown color. It's actually really hard to get a pure black, which is why when you're trying to create ink and have something have a clear black, they just create black ink to do it. Instead of combining the magentas and the cyans and the yellows, you have black ink as well to get a really rich black. So that's why when you buy ink for your computer, it comes with a little black cartridge as well. I put some websites up here if stuff is confusing you. There's some really good kind of resources. So if you look on my PowerPoint online, you can link straight to these. I think that might be it. Wow, that was faster than I thought it was going to be. Okay. All right. So I'm going to finish my recording. Stop recording.